So, hi, my name is Mike, as you already know. So, I'm a software engineer from JUNO, and I'm going to talk today about the code design and to tell you a little story about one package, how you can do it in the GoWay. So, because I'm the first speaker today from JUNO, I want to say just a few words about the company. So, we are doing ride-sharing service like Get, really, but we operate only in the USA, and because we are in the beta stage, we do it only in New York at the moment, but we are going to expand to other cities in a few months. So if you're going to visit USA and New York, try JUNO, it's cool. And let's start from some technical stuff we have. So we have really huge code base. It's about 250,000 lines of codes. We have about 70 microservices. Primarily, they're written in Go. We had some services before written in Python, but at the moment we left only one service because Go doesn't fit this place. All the services are running in the AWS cloud. We in hundreds of containers, so they handle thousands of RPS every second. And all the stuff is created and supported by a team of 40 engineers. And this number includes the software engineers and QA engineers as well. So when you have so huge code base, it's very important to understand and remember that when you write some code, you do it not only for machines. The code you write it for humans, because for machine it doesn't matter how you call your variables, functions, or interfaces, how you place them into files and so on, because machine just run it and that's all. But when we have a lot of code, a lot of services, and a lot of people, we want to make the code we write to have it reusable between teams and to make it clean to read, understand, and modify. When you write some code and check into the source control system, you have to mention to understand that since that moment the code you wrote belongs to the whole team. It's not your own individual code, because the whole team will support and modify this code in the future. We take care of code very much, so we have a very strong code review process for every line of code we write. So when we do code review, we have rules that each pull request has to have at least 2 approves from members from our team, and it has not to have any disapproves, because when I review somebody else's code, when I make the proof for that, I says that okay, that code is great, I understand what it does, and I'm ready to support it in the future. So this is the picture how our code review process looks like. So sometimes if you write good code, you can get just few comments like, what the fuck you did, man, so please re-implement it. Or if you can get a lot of problems and comments. And this slide is really like some bullshit bingo terms, because we want to write clean code. We want to write the GoWay idiomatic code. And what does it really mean? So the simple code is code that solves some problem without some additional complexity. So the adaptable code means that this code is ready for some requirements change in future, and it allows you to create some tool or library to make it reusable in some other issues to solve some our problems or to make it usable in some other service for other tasks. And when you write code, it has to be testable. We do not write tests for the tests, because the most important thing about this point is that you write tests, you write the code the way when it's really testable. So it allows you to design your code more modular than it can be. So, and the story I want to tell you is about one little package or library that we created. So let's start from the problem. Imagine you have some system consists of a few components which communicates with each other. So you have two teams of engineers, and also you have some third-party service, and one of the services communicates with. So all communication is done via HTTP, and after start, the code was written just to work, so it was pretty simple. And in source code, guys just used the simple HTTP client struct to communicate. But one man from Green team decided to improve it because he wanted to add some more features to the client. And he decided to write the awesome HTTP client. So he started from simple Scratch code. So he created the struct HTTP client with only a single field where HTTP client was, and created the do method, which really just calls the original client. So after that, he started to think what features his client has to support. And he started from authorization because one of the services in his system requires HTTP authorization. So this is must-have feature. After that, he added the logging mechanism to that because he wanted to debug his code and understand what he requests go into the system. So, because he understood that there are some problems sometimes, so he added instrumentation to this code, like metrics, to understand how many requests they do, how much time they take, how many errors they get, and so on. Sometimes error happens, and he added the backoff retries to client to make retries to avoid some problems. And because they use client-side service discovery, so he needs some load balancing mechanisms also in the client. And after all this work, the code looks like this. So, and when you look at this code, it says to you, yes, I'm like a mess. So, because really, let's take a look at it. So this client does all that stuff from the previous slide. So he has support for HTTP authorization. He can log all requests. He can measure the time, the errors. He also has retries inside. But really, when you try to write some tests for that, you'll understand that, hey, I want to test that my client adds some header. So this stuff is done in the first line. But when I want to write test, I have to, first of all, because this code calls the original client, you have to run the in-process HTTP server which will respond to this query. And also, you have to set the retry attempts minimum to 1, because if you don't do that, this loop won't do any iterations. Then you have to set some backends to the backend slice to avoid some panics. You have to mock the logger inside. You have to mock the summary for metrics, and so on. And you can do that. You can write tests for every feature, for authorization, for retries, for logging, and so on. But when you add some feature, you have to modify all tests again, because you can add some more dependency to the client, and you have to mock it also. So let's think how we can modify it and make it the Go way. So, but really everything is already invented, and let's take a look to the standard library. So it provides some few cool stuff. First of all is HTTP handler, which just interface with single method, which accepts response writer and request. And also we have cool handler func, which implements the same interface. It allows you to not create structs with which implements this interface. You can just define a func with this signature. So also there is a cool approach, middleware. Who's familiar with middleware? Okay, so for those who don't know, so it's the way when you can wrap some your handler with some middlewares. You can think about like just a standard decorator pattern. And when your request comes to your system, the first middleware is the most outer. So it comes to the middleware C, then it comes to middleware B, then in middleware A, then it comes to the handler handles it, and then it returns back in the reverse order. So it fits the server side very good. Let's project to the client side to think how we can improve it. So let's start from the client interface. So we do the same. We create interface with just single method, which copies the original HTTP client method and create the same functions as we have for handlers. So we create client func, and we create implementation for client func, which allows us to use the client func as client. So is it clear for you guys? Yeah, cool. And also we define the middleware type, which accepts some client, can do something like that, and return another client. So, and let's start to implement the features from the original client into this way. So let's start from logging. So we create simple middleware which just logs the information that we make some call, and after that we just call the next client into the chain. It allows us to make this small piece of code and to make it to write tests for it, because in this case you don't need to run any internal HTTP server. You can just define some function client which will assert that in this case you can just mock the logger and check that really the logging was happened, and the client you passed here can do really nothing because you don't need to check into your tests. The next thing is headers required for authorization. So we add the simple middleware which just adds specified header to the request. And in this case, you can easily test it. You can create some function which just asserts that request contains header and pass it as client over here, and that's all. And using this simple header middleware, we can go forward and create the basic authorization middleware, which is helper to use the HTTP basic authorization. So it encoded the username and password and called the header middleware to add the header to the request. So also you can easily test it without any additional mocks. So we can do the same stuff for metrics, which is also testable. Then you can create a big-off middleware which performs retries with some configured delay, so on. And in this case, you can use different strategies for because you can use some external libraries for that. And the load balancing. So here is just the simple implementation which accepts some slice of available backends, and it just chooses the random backend from the slice and put it to the host to the original request. Also, yeah, sure, this is some shit here. So also you can test it like the hero middleware without some additional work. And this is some helpful middleware because you can write or use in your middleware some third-party code which can has some errors and can panics. So this is middleware which recovers all panics and converts them to error. And really all these middlewares are just Lego bricks which has the same interface, and each of them, so here they're different colors, but in your case they have different functionality. And as Lego bricks you can combine them in any order you want. So for that we can create the chain method. And for that we create chain method which accepts the client and some slice of middlewares, and this function wraps the original client with all specified middlewares. So, and we get the picture like I showed you before. So, and this allows you to wrap middlewares around your client, and when you call it, so the request comes to the first middleware, went to second, so on, then we do real HTTP query request, and then it goes to in the reverse order. And this allows us to re-implement the original client in this way. So we get the HTTP client, we add the logging middleware, then we add basic authorization middleware, the metrics, the backoff, load balancing, and recover to avoid some panics. And when you see this code, you really understand how your client will work, what features he supports. And this allows you to give this library to some other team, to some other project. For example, in another service you don't need authorization at all, so you can avoid basic authorization middleware, or our project uses another matrix or another logging and so on. And there is a good practice in Golang that says accept interfaces and return structs. This means that when you write some code and you create dependency for some struct from another package, for example, really don't do that, because you need to depend on the behavior, not the concrete implementation. So what does it mean in real world? So for example, this is example of one of our libraries we wrote. So we have the client to the Zeus project, it's the payment system. So we have a very high-level client which has HTTP client, and the HTTP client is interface which defined in the same package. So there is no explicit dependency to the HTTP client struct. And when we write some code in this way, it allows us to mock this high-level client as well without real HTTP calls, and this allows us to inject the stuff we use for all internal communications, because when we make calls between our services, we measure all of them, we add some logging, we also use open tracing, and if you just inject the original HTTP client. There is no way to inject this stuff there. So really there is, you can hack it via round tripper. You can make the same things with round tripper and inject it there, but the documentation says that when you re-implement the round tripper, you don't have to modify the original request. So this is just a hack. And this is a good way how to do these things. And I looked for our vendor directory and I found a lot of projects that do not do such things. So they all accept just HTTP client, or even they create HTTP client inside. So you can only pass the host, for example, there, and the client is created internally. And that means that there is no way to add some additional functionality to that client. So you neither can really log the real request which some of this client makes. And you know, the standard Golang library, just this box of Lego bricks, it provides you some basic things and some basic patterns and practices. You can combine it. And when you write some package or two, don't invent your own patterns, because really there are a lot of libraries which allows you to do the same stuff with HTTP requests, but they do not have support of standard library. So you have to create the requests with their own API. You have to make code, so there is no do method. So there is some another request struct, there is some another send or do method, and you can just make drop-in replace from the original HTTP client to some third-party client. So look at the standard library and look at some practices which are common in Golang community and the standard library. And you know, I think all of you have ever read these links, but these links is like some books about some programming and so on. You can't just open it, read it, and says, I know not anything. I know everything. You can read a few pages, close it, think about that, and after some time you realize, yeah, there is some good ideas there. And do the same with these links. There are really good practices and patterns how you can write the Golang code. And there is a very cool quote of Rob Pike that simplicity is really a complicated thing. Even you think that you create some very simple package, think how you can create it in another way to make it reusable, and always be respect for your team and other developers. So that's all. Thank you.
Okay, any questions?
Hello. So Go compiler's pointer escape analysis is known to be very stupid. So basically, if you return a pointer, it happens to be in a heap allocated block. So if the chains of those middleware are going to be long and will be called frequently, you're going to face the fragmentation problem. How do you handle that?
So really, the chain, in the real world, the chain isn't long enough. And when you make the external call, and in this case HTTP call, so the time used by garbage collector isn't sufficient. So it takes really small time in comparing to that external HTTP call. So in some cases, really, if you have some problems with garbage collector and you have very high throughput, so you can avoid these things to write high performance code. But I think in real systems there are just they can be just few points that it's required, and you make it because it's required because of performance. But when you do some general purposes, libraries or tools, do them first in this way.
Okay, thank you.
Hi, Mike. Two questions. So basically, you are just suggesting using this small interface like do and request response. So yes, it's a good idea, but why can't we just use more broader interface? So your suggestion is stick to HTTP protocol. And what if I just wanted to use maybe direct TCP calls or whatever?
I think you can do the same with.
But those structs, request and response are really stick to HTTP.
So if you want to do the same things with TCP calls, yeah, of course you don't need the HTTP request and response. So you have to create some interface and create middlewares for the low-level TCP connections.
Yeah, so what I'm asking you, because we can just provide a more broader interface without this HTTP structs inside.
Yeah, but this example is about HTTP clients. So, for example, in JUNO we create the same things for all clients, for example, for Redis, Mongo, and so on. So the original libraries provides you just a struct. So, for example, I don't know, Redis client, yeah? And the constructor in this package returns you just a struct. So there is a pointer to Redis client. And on our side, we create the same interface for that, which has the same methods as that client, and we create wrappers, decorators for that. So for all external calls like HTTP calls, database calls, cache, and so on, they do these things.
Okay, so basically it means that your business code is aware of which protocol are you using now. So it's like HTTP.
No, of course, no, because in business code you make a dependency to the client. So this client is defined nearby, and it has this.
Yeah, so it means.
And when you decided to use this library, you can just use the original HTTP client if you don't want to add some additional functionality to it. Or we use our own client, which has these middleware features.
Okay, and the second question is, have you tried gRPC?
Really, no. At JUNO, we don't use HTTP for communication between services. We use it only for external calls. So internally, we use two things. The first one is NATS to communicate between our services. We use the request response model for it, broadcast, and so on. And we use SQS for some queued messages. So this talk is about our external calls.
Okay, more questions? No. Thank you.
Thank you.